Okay, welcome everybody. I will be putting a bit the context, the ground for the presentation that Enrico will be giving today. You will see that our target problem is the use of AI solutions on safety critical systems. These are, let's say, solutions we really need in our systems because of the need of this computer vision for object detection and autonomous navigation. I would say that this is, let's say, the main problem that comes to our minds when we think on this challenge. If you think on what you have in your cars, in the planes, or I mean, in any critical system as of today, you realize that we already have AI inside those systems. But the thing is that normally this is embedded into fail-safe systems, meaning that these are functionalities that eventually, if they fail, can be disabled, and we can simply transfer the control to the driver or just disable the system to some extent. So in essence, this means that this AI software is not inheriting safety requirements. So this makes that as long as this AI software has enough quality, we can use it, which is good, but it's not what we need when we want to move to fully autonomous systems. When we move to fully autonomous systems, we cannot simply just disable for instance, the object detection and the navigation of the system because perhaps there's no driver, perhaps there's no steering wheel in your car. Okay. So this is the challenge we have, how to make AI software to fit into the, let's see, the safety compliant development process of software. And we realize that the challenge is huge. Why? Simply because this AI software is developed normally, let's say, in the opposite manner that you would develop software for a safety critical system. So its development process is empirical, is based on data. It's not a control algorithm that then uses data. It's software that is developed using data for training. It's not correct by construction. I mean, it's not some software that is always providing the right answer. I mean, you know that there's some accuracy, some mispredictions, and this may happen. And this is something that was not conceived to happen in safety critical systems. And also the software architecture, I mean, goes against this divide and conquer usual strategy we use in safety critical systems. So the ambition of SAFEXPLAIN of the project, and I would say that we are really, really close to achieve it, is to enable the certification or qualification, depending on the domain, of AI software, in particular deep learning solutions in safety critical systems. This means that we have to adapt the development process to include, let's say, a specific process for AI software. I mean, we want to make sure that this process allows us to provide guarantees that the AI software will comply with the specific safety requirements. This was, in fact, what was the focus of the first webinar of the series. I mean, the way to achieve this is to add, let's say, a level, let's say, some levels of supervision and design that in essence this is something that was also presented in the second webinar in the series. Typically we built on AI components for explainability and a specific software architectures that provide all the layers around, and then integrating a number of monitoring and diagnosis capabilities and let's say this leads to, let's say, to software architectures that have non-trivial interactions, non-trivial requirements. This will be the focus of the webinar today. Of course, this software can only run in, I would say, a complex beast delivering that performance. Normally, we are resorting to very high performance platforms with multi-cores, accelerators such as GPUs, and also AI-specific accelerators. And this brings an additional level of complexity that needs to be mastered. I mean, this is also focus of the discussion that we'll have today. And hence, at the end, what we realize is that we need some platform support, some toolset support to support these software architectures, to manage the complexity of the hardware, to support the verification and validation process, and also to provide a standardized interface for the applications that will run on top. So as you see, there are a number of topics and concerns that need to be considered from the platform and toolset side, and this is the focus of the webinar today.